That was our problem on the first level where we made our answer one level complicated, right? Let's take this, make it one level more complicated. So what we're going to do is we're going to deal with each term individually. Now this one all we're going to do in this round is probably just remove the brackets. Actually, we might go a little bit further. I might just remove the brackets in this term and just explain that, and then just kick it up one more level, okay? So we're going to deal with each term individually and make each term more complicated. Let's start off with 5 square root 5. Now, 5 square root 5, what we can do to make this more complicated, or make it look different, I don't know if it's more complicated, make it look different, do a little more for it, is just bring the 5 inside the radical symbol, right? Now, square root, again, this means 2 here is an invisible 2. If you go on any level higher, if it was a 3 or 4 or 5 or whatever, you write the number there. When there is a number, it just means a 2. So when you take this number inside, this number comes in here, the rule is, this is a boundary, so it clones itself twice. So you multiply the clones together. So when this guy comes in, it becomes the square root of, we've gone over this before, so I'm just going to write out what the final answer would be, right? So this would be, if we brought it in, it would be the square root of 125, and the square root you could just write as to the power of a half. So I'm going to write this as 125 to a power of a half. And that is the same as that, because that's the square root of 125. And 125 breaks down to 5 times 5 times 5. And when we have the square root of 125, the square root means you're looking for couples, pairs. You grab 2 of the 5s, and you bring them out, and you get 5 square root of 5, okay? So this one we've taken care of and made it look complicated. Or made it look different. This number. Now, I'm not going to do the same thing. What I'm going to do is multiply this number by 1, right? Like we talked about before, you can write any number in any form you want. Like for example, number 4 can be written as 8 over 2. Now what that really means is I multiplied, number 4 can be written as 4 over 1, right? Now what I did was multiply number 4 by 2 over 2, which is basically 1. So the number 1 is super powerful because it's used in multiple places, a lot of different tricks when you're rationalizing denominators. We haven't talked about that yet, but this is a really important concept where you can multiply any number by 1. Now it's your choice what 1 looks like. For us, for this one, I'm gonna multiply, make my 1 look like, let's do this. We're actually going to do this this step. So this becomes minus. We've got a minus here, right? Now we're going to deal with this. I'm going to take this and make it, just write it out, 3 square root 5. And I'm going to multiply this number by the number 1, and I'm going to choose 1 to be 2 root 2 over 2 root 2. So I'm going to multiply this by 2 square root 2 over 2 square root 2. Now, if you remember your fractions, when we're doing our fractions, this will kill this and this will kill this, so that's just 1. Now, 3 root 5 is just 1, right? So when you're multiplying fractions, top multiplies top, bottom multiplies bottom. So 3 square root 5 times 2 square root 5, the number multiplies the number, radical multiplies a radical. 3 times 2 is 6. Root 5 times root 5 is root 10. So this guy, we're just going to break it down and then just write out the whole thing down here. So this guy would be 6. So this is going to be minus 6 square root of 10 over 1 times square root of 2 is just 1 square root, or sorry, 2 square root 2. 2 square root 2. And I'm just going to bring this guy down. So this is 125 to a power of a half. And that's 10. Okay? Now if you want, you could have just written down as a square root and then made the transition. If you wanted to do that, you could have written down as a square root and then just made the transition to an exponent when we went to the next level. So far, we've taken these two numbers and made them look more complicated. Let's deal with this guy. With this guy, what are we going to do? First thing we would do is remove the bracket. When you drop this bracket, this negative number applies to everything inside the bracket. Now, this is positive a squared cube root of a squared. So the negative side just multiplies the positive. So this actually just becomes minus this. So this one's fine. You can leave this one alone. We're not really leaving them alone. There's a 1 here, and the 1's multiplying this and this. When you multiply this by -1, it is a -1. It becomes negative that. And this guy becomes, you just change the sign here, and it just becomes minus, and your bracket is gone. Okay. So you just killed your brackets and applied the negative number here to this guy and this guy. So how are we going to write this? You know what I'm going to do with this? I'm going to do the same thing I did with this guy, which is bring this inside the root symbol. Now, when you're bringing this guy inside the root symbol, this is the cube root of this thing. It's the cube. The boundary says triplets. You need triplets to go from here to there. And if you're coming in, you got to clone itself 3 times. So this guy goes in here, and it becomes minus, because it was a minus the cube root of, should we write out the whole thing? Actually, let's write it out. I'm going to write it out really small and then just convert it down here, okay? So this thing is going to clone itself 3 times, so it's going to be a squared times a squared times a squared. That's that guy, and we already had one of these guys here, right? So that's going to be a squared. So when you're multiplying anything that has the same base, all you do, you add the exponents, right? So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. So this guy just becomes minus, here's your a to the power of 8, right? And we talked about the radicals. The radical here is just really can go in the exponent as the denominator. So I'm going to take the cube root here and move it to the exponent, and it's just going to go under here. Okay. So this is a to the power of 8 over 3. So this is 2a squared, right? So let's deal with this part first. 2a squared we can write as 4 over 2. So let's write our fraction. So that's our fraction. So this becomes minus. 2 I can write as 4, 2. So 4 divided by 2 is 2. So we're cool there. That works. A squared. I'm going to write a squared as a to the power of -2. Because if you remember, when you had the integers, a negative exponent, if it's a bottom, it just kicks up. So this guy would just be a to the -2, and it would just convert to that, right? Let's go with this thing. Let's cube root of, that's a squared. I'm going to make that a to the power of 5. Now, I can't just change something and not compensate for it, because we need our original, right? We're trying to work our way out. So what I'm going to do is, that's a to the power of 5. That's a squared, so I need to take away 3 from that 5, right? And the way you take away with fractions is, with radicals is, when you're dividing by something, with a power, you subtract the exponents, right? So this would be, and remember, we still need this radical because like terms deal with each other, right? So this is going to be the cube root of a to the power of, we need that to be 2 to the power of 3. Now, we could have written that as a single a in the bottom, but again, it would have just made things more, a little bit more messier. But I think I like this one better. It looks ugly. So let's rewrite this. So this would be 4 cube root of 8 by 2, 8 by 2 cube root. Messy, messy? How does that look? Ugly, ugly. So basically, this would be a more complicated question of the previous one, where you could have gone, they would have given this as number 2, question 2, and they would have said, simplify this.